So we're going to, this chapter, which is about polynomials, we're going to do it in 4 lessons. And they're not going to line up exactly with the way the book does it. So you need to pay attention to what we're doing in class. There's going to be like 2 lessons, including today's lesson, which are using the calculator a lot. Okay, it's teaching you to do things in the calculator that we're supposed to know how to do, and we might have done it before in earlier chapters, that I was just saving it up to do it once we could do it with all these functions. So you'll see it today. And because you can't take home the calculators to do the homework, I can't assign those kinds of problems in the homework. So your experience with it is going to be right here in class. And we'll probably do a little bit, every day just to remind ourselves how to do it. Okay. So I would think that this chapter, you'll probably think this chapter is not as hard as the last chapter. But the next chapter is definitely harder than the last chapter. It's probably one of the top 2 hard chapters, the next one. And then there'll be one more chapter test before we get out for the semester, and it's probably medium, somewhere in there. So let's see. I'm combining 2 different lessons, or taking pieces of 2 different lessons here. The polynomial functions from 5.1 is going to introduce us to polynomials. And then the polynomial models is talking about using the calculator to make equations for scatter plots, which is something that we could have done with linear equations, and we could have done it with quadratics, and now we're going to do it for linear and quadratic and the polynomials that we're doing today. And I'd say, most of the time, I teach the regular algebra 2 twice, and then I teach you guys, and there's always something that's different with you guys that I can talk about more stuff with you guys. They're not much different in this one. There's going to be only like the very last thing, and I don't even think it shows up in the slides so much, but I will show you one more extra thing that I didn't show them, just because I think you can handle it. That's why. Right, so by polynomials, we mean many terms. Poly for many, right, or many for poly, whichever way, and terms, right? Now, what do we mean by terms? Terms in an expression are separated by pluses and minuses. Pluses for addition, minuses for subtraction. Not like negative signs that you might still think you're doing a multiplication there. So something like 2x squared that I wrote down below, that's one term, right? You don't think of the 2 as a different term than the x squared. That's all one term because there's no plus or minus separating it into 2 terms. Right, so how many terms do you see in the polynomial expression on the left? There's 2 because there's one plus sign, it's dividing it into 2. When an expression has 2 terms, you call it binomial. And we have seen that already. Binomial. Okay. In the equation, the expression on the left has how many terms? 1, 2, 3, right? 2 pluses dividing it into 3 terms. And what do we call it when it's got 3 terms? Right? We've seen this, right? In the last chapter, we had 3 different kinds of trinomials that we looked at. Simple quadratic, not simple quadratic, perfect square trinomials, right? So this is a trinomial. Okay, and the function at the end, where it's y equals a polynomial expression, how many terms are in that? 4. When you get above 3, you just say polynomial, right? Polynomial is for 4 and above. When you, we were going to do a little bit of practice of, it's mostly about vocabulary more than anything, which is, how do we refer to polynomials? And the way we refer to them is, number 1, by the number of terms, like I just explained, right? Number of terms. And then the second is what's called the degree. The degree of a polynomial is the highest, it's the highest power term. whatever is the exponent of the highest powered term. So in the first one, the highest power of x term is x squared. What do we call something that has a squared term? Last chapter, title of the chapter? It's a quadratic, right? So by degree, you would call anything that has an x squared as the highest power term, that's called a quadratic. We've already done quadratics. Quadratics are polynomials, right? So that one you would know. Linear, we've done that before. Linear means x to the first. So I'm going to set that aside here, like 2x plus 1, right? Okay, if it's raised to the third power, that is its own word, which you probably are familiar with, cubic. Cubic for x to the third. And then to the fourth power, as in the function right here, that's called quartic. Quartic. Right? And you have to recognize those words. You'll see why by the end of this lesson. Quartic. So polynomials have many terms, and many terms can be anywhere from one term to, more than 4 terms. We generally don't deal with that long of polynomials. And besides the number of terms, there's degree. Degree is the highest power of x of any term that you see. Right, there is a table. Oh, let's wait a second. Okay, we ready? This comes from the book. If it's hard to see, look in the book, section 5.1. Right? And it's giving us the examples of classifying polynomials by degree and number of terms. So you can see all the different kinds here, which we've already talked about. Linear means x to the first. Quadratic means x squared. Cubic means x to the third. Quartic means x to the fourth. There's actually one beyond that we give a name, quintic. Quintic is x to the fifth. And there's actually one before linear, right? A constant function is just a constant, like 5 is a constant. And that is considered to have a degree of 0, right? Because if I write 5x to the 0, what is anything to the 0 power? 1. Anything to the 0 power equals 1. So you wouldn't write an x to the 0 because it's just 1 anyways. But if you just see a constant, then you're going to say, okay, that has a degree of 0. Okay, let's see. So those are the by degree. If it was more than that, like if it was degree was 6, you would just say 6 degree. Don't worry about it. If you see an x to the 10th, okay, 10th degree. That's it. Now, when it comes to the number of terms, again, we see the words that we've already introduced. Right, the first one has 1 term, so it's monomial. The next one is 2 terms, so it's binomial. The next one is 1 term, so it's another monomial. Okay, the next one is 3 terms, so that would be trinomial. 2 terms again, binomial. 4 terms, 4 or more, just say polynomial, right, for many terms. Now, every one of these, right, every one of these expressions that they wrote in there, to the degree that they could, right, is written in what's called standard form. Standard form means the highest power term is on the left, and then it's in decreasing order of the exponents, or the size of the exponents. So like this one right here, 4x to the third minus 2x squared plus x. right? That it's in standard form because the highest power term, 4x to the third, is all the way on the left. And then the next highest power term is 2x squared. And the next highest power term is x. That's standard form. What was I going to say there? There's no parentheses. Here's your x to the fifth, x squared, x, and constant term. So that is the standard form. Again, here's x to the first, and again, the 4 by itself is an x to the 0. So 1 and 0. Good. Okay, so let's see. We are going to take these two problems, which are examples out of the book, and first step is put them in standard form. That's what the directions are going to say, right? So you put it in standard form, and then you classify it by degree and by number of terms. Okay. In this first one, 3x plus 9x squared plus 5, what kind of rearranging do you have to do to put that in standard form? The 9x squared ought to have been first, right? And then the 3x and then the 5. Okay, what about this one here? Say again? What do you mean by simplify? Combine like terms. If you got any like terms, you need to combine them. Before you start putting things in order, you got some like terms in this expression. What are the like terms? Yeah, these two are like terms, right? Because they both have x squareds. Remember, like terms mean same variables raised to the same powers. So x squared terms are like. How do you combine like terms? Add or subtract what? What do you call the coefficients, right? So you're going to combine these two numbers. Negative 6x squared plus 10x squared is 4x squared. Remember, you add x squared terms, you get an x squared term. It doesn't change it to x to the fourth, right? It's like adding, 6 apples plus 10 apples. You got 16 apples. They're still apples. Right? Don't change the power when you combine like terms. So there's the two in the standard form. Okay, then classify them by degree and number of terms. How about the one on the left here? By degree, you would call it by degree. Quadratic. If I say by degree and you say trinomial, you just got the question wrong, right? That's not by degree. Okay, so that's a quadratic. Now, how many terms? Trinomial. By number of terms? Okay. And how about this one? It is a quartic. And by number of terms? Polynomial, right? So not too hard, huh? That's what the homework is all going to be problems like that. Because most of what we're doing today is going to be stuff on the calculator that I can't send home with you. So go ahead and try to do the same thing with these here. Put them in standard form, classify by degree and number of terms. Were there any like terms? Where did you find the like terms? In B, and what were they? The 3 and the 10, right? So you have to combine these two. Yeah, make sure when you're like moving terms around like that you keep the sign of the term, right? Don't lose the sign. I see a lot of mistakes of that. Like this this 4x to the 5th has got a negative in front of it. So when you rearrange, it's still got a negative in front of it. So this, let's see, this one in standard form would have looked like 5x to the 4th plus 3x to the 3rd minus x. Okay, and classify it. Say again? Say again? Quartic. And how many terms? 5 terms? Quartic trinomial. Highest degree term is 4. Okay, what's this one look like when I put it in standard form? Negative 4x to the 5th plus 2x squared plus 13. Okay, classify that one by degree and number of terms. Quintic trinomial. Oops. Think you can handle problems like that? It's kind of vocabulary because, I mean, especially when it comes to monomial, binomial, trinomial, you got to know what those mean, right? It just is a vocabulary thing. You know, we're expected, if I use the term, that you would say, oh yeah, I can picture what you're talking about. And as far as the, you know, constant, linear, quadratic, cubic, those are very well, you know, used a lot. Quartic, not so much, but you're going to see it in the course of what we're doing in the calculator. Quintic, almost never, right? I mean, but you should know what it is. Quintic, you can kind of figure the root word there, quintic 5. Okay, so now you don't have to write this one down, okay? But in chapter 2, we learned how you could take 2 points and come up with the equation of a line. And it involved using this form of a line. Y minus y1 equals m times x minus x1. Do you remember what we call that? It's the point slope form, okay? But we don't have the slope. So how did we start? You got 2 points, find the slope. So first step was this. We did m equals 8 minus 2 divided by 5 minus 3. Right, which is 6 over 2, which is 3. Okay, then what did we do with that? You put the 3 in the place of the m, and then you chose one of these points to be your x1, y1. And I'm going to pick the one that's smaller because calculations maybe are easier. Y minus 2 is 3 times x minus 3. Y minus 2 equals 3x minus 9. Add 2, y equals 3x minus 7. So keep that in the back of your mind. Now, I'm going to show you how you could have had the calculator do that for you in very easy steps, okay? And this is where you need to be playing along, doing this with your calculator. Okay, calculator time. Okay, now first, so that we're all starting from the same place, let's clear memories. Do you remember how to clear memories on these things? Okay, so it's something else you need to know how to do, right? Second plus key is memory, okay? To reset, then you go to 7. 1 for all RAM, 2 for reset. It should give you a picture that looks something like that. Okay? What's that? Let's see. Second plus 7, 1, 2, done. Okay? So once you got that done, if you hit enter again, it'll clear the screen. Okay, in order to put the data in the calculators, in this case the data is just 2 points. You go to Stat, Edit, and Stat is this button right here. What do you think Stat is short for? Statistics, right? So you go Stat, and you can see on the top of the screen, right, the Edit Calc Test. We want the edit, so just hit Stat, Enter, basically. Right? Now, there should be lists there, starting with L1, and then L2, and then L3. Does anybody not have it starting at L1? Okay, if everybody's got L1, that's good. Okay, you're going to put your X values under the L1 and your Y values under the L2, right? So the X values in this are 3 and 5. So you go 3 and then hit Enter right away, and then 5 and hit Enter. There's my X values. Now right arrow over to go to the second column for L2 and put the Y values, 2 and 8. 2, Enter, 8, Enter. So it should look like the points, right? 3, 2, and 5, 8. So everybody got that far? Okay. Next. Next, you're going to go to Stat, again, but this time arrow over to the Calc. Right arrow over to the Calc. And you can see you're going to hit number 4, and number 4 says lin reg. The LIN is for line. We're trying to make a line that goes through these 2 points. Now, when I hit that, my screen looks like that. Your screen doesn't look, your screen looks like this, right? So that's why I put that up there. So you can see it, and it says the X list is under L1, the Y list is under L2, and you don't care about these things in the middle. You just want to go down to where it says calculate. Either hit Enter, Enter, Enter. Eventually, when you hit Enter, it'll bring up that. And then when you hit Enter again, it gives you Y equals AX plus B. It's kind of like Y equals MX plus B. They just use an A instead of the M. And then they're telling you the values of A and B. So you have to substitute. When you get this screen there, you've got to write the linear model for this is Y equals 3X minus 7, which is what I got in the last slide when I did it the long way. Right now, how many points does it take to determine a line? 2, right? So we can be sure that with 2 points, when we found a line that goes through those 2 points, that's the only line that goes through those 2 points, right? That goes back to Euclid's 5 postulates in early Greece, right? So we know with 2 points, we just determined the one line that goes through them. So if you had to do this kind of problem, you actually have a way to do it now in the calculator. I mean, even if you had to do a kind of problem where it says, here's 2 points, find the slope. Well, just do this, and which number is the slope? The A, right? The A. So, I mean, you have a way to calculate slope now between 2 points. Okay. So try to do, if we're doing all right with that, try to do those 2 points. Come up with the equation of a line using the calculator that goes through those 2 points. Remember, Stat Edit to enter the data, Stat Calc 4 to make your line. Correct, correct, correct. You get it? What's the aim to be? Good, good. Mark, you get it? Yeah. That's right. All right. So, is anybody not having success entering the data? Yes, no, that's wrong. So if you did all the steps right and you don't get the right answer, You didn't put the data in correctly. Go back to your data and see if you got the exact right data. You know, I think some people are putting under L1, you're putting 7 and then 11. It's supposed to be X values, right? So 7 and then 13 in the L1, 11 and then 17 in the L2. Right? So what it should have looked like, if you did this correctly, you should have got that screen right there. Right? Now, you shouldn't have stopped there. You got to write the equation. Right? You got to write the equation. So it's y equals, yeah, if you say 1x plus 4, that's okay, but you really should write y equals x plus 4. Right? You usually don't write a 1 as a coefficient. You assume 1. Right? So y equals x plus 4. So again, that's a way to make the equation of a line that goes through 2 points. But what if there's more than 2 points? Well, what happens if you've got more than 2 points? That means that it may be that they're not all on the same line. Like these 3 points, there's no way you're going to draw one straight line that connects those. Are you done? Okay, I'll just stop. That's always an option. Okay. There's no way to connect these 3 with one straight line. So instead, you're going to draw a line in the middle of the points and try to make it the best approximation of where those 3 points are. I mean, I can do this. Right. Where's that? I don't think I got it. There we go. You know, I can take the line and just kind of like play with it. You know, would it look better there and then maybe down like that? You know, and you kind of play around. What you're really trying to do there is to minimize the distance between the points and the line vertically. Like this is an error right there because the line is not going through the point, right? And this is an error right there, and this is an error right there, right? We're just trying to minimize that. And, you know, there's many words for this. When you get into future math classes, they call that a least squares because of the way we find that minimum thing. But the calculator is going to do all of that for us, right? It's going to find the best line through those points. And that line is called the best fit line. Or in this section in the book in 5.1, actually this is going back to like 2.7 or something, 2.6, they call it a trend line, right? The trend line. But the real name for it is it's a regression line. Do you remember when you went to that menu, Stat Calc 4? What did it say? It said LINREG. The REG is for regression. Regression. So it's really a regression line through those points. So in order to find the best fit line or the trend line or the regression line, you do exactly what we already did. Right? You just enter the data, and then go Stat Calc 4 and see what the line is. So let me do that one up here. Stat, enter. So my X value is 02378. 02378. And then scroll over. You know, when you scroll over there, you know, if you do it without looking, you may not realize that it's right underneath the data you already entered, and you need to go up so that it's across from the 0, you're putting the 11, right? 1187. Okay. So once you put in all the data, you're going to go Stat Calc 4 calculate, just like you already did when you only had 2 points. Stat Calc 4, and like you guys will have that different looking screen that go down to the calculate, and you should get that. Which is common, you know, that you're not going to have always nice whole numbers as integer values for your coefficients. You know, it could be decimals. And you don't want to be writing this many significant digits to the right of the decimal point. You probably want to cut it off, like maybe 2 places. Maybe this could be negative 1.33x plus 10.90. Okay, so that's how you make a best fit line. I rounded, did I? Did you hear what I just said? I said you probably don't want to keep all those decimal places, so I rounded. Okay, try that one. Try to do the same thing. Find a best fit line, regression line for those 5 points. Yeah, I don't like that. Who's got an answer? Let me see that. Negative 0.71, that looks right. That's right. That's right. That's right. Correct. That's good. That's your own calculator, huh? Okay. So what did we get for the coefficients there? I think I've got it on here. You know, and so probably round off. It ought to be these. Right? It ought to be these. If you didn't get that and you went through that, you'd put the data in, right? Do you send that? Okay, stat, edit. Okay, you don't have the right data in there. I just gave you 5 points. Where's the 5 points? Yes, all 5. You can't just use 2 of them. Yes. I cannot hear you. Quiet. What? Yeah, that's good. Okay. Now, the thing is, when you went to that option, the menu, right, stat calc, there was actually more options there, right? 4 was linear, but we should recognize the next 3 now because of, you know, what we learned at the beginning. I mean, quadratic, we kind of already knew. So you can make a quadratic regression. You could make a cubic regression. You could even make a quartic regression in your calculator. And if you keep scrolling down the list, there's actually other kind of functions in there too, which eventually we get to. If you look at the SOL, it says you got to do all these functions plus exponentials and logarithms. Now, you know, the fact is it's still the same procedures. Enter the data, click, 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 and then stat calc, find your function. There's your equation. But how are you going to determine which one you're going to use? You have to look at the data and see which shape does it look most like. Well, let's see. Linear, we would have a pretty good idea what the data, if it was linear, looks like. And even a quadratic, what's the shape of a quadratic? It's kind of like a U, it's a parabola, right? So we don't know what that looks like. The other 2 we may not know, but this is what they look like. So starting with linear, right? We know what a straight line looks like. If a straight line has a positive slope, then it looks like this. If a straight line has a negative slope, it looks like this. Right? From the last chapter, we know what we mean by a, ax squared plus bx plus c. When the a was greater than 0, the parabola opened up. When the a was less than 0, the parabola opened down. Okay, now cubic functions either look like this or they look like this. And again, it's all based on the first coefficient, the a. It's also called a. In this case, if a is greater than 0, it'll look like this shape. If a is less than 0, it'll look like this. And for a quartic, same thing. A greater than 0 is this, and a less than 0 is that. Now, we are also supposed to notice that as we keep increasing the degree, the graph gets a little more complicated. Like a straight line is not a complicated graph. It's a straight line, no change in direction. A quadratic has how many changes in direction? 1, right? 1, whether it's opening up or down. A cubic is how many changes of direction? 2. A quartic is how many changes in direction? 3. How many do you think a quintic would have? 4. It's always 1 less than the degree. That's how many changes of directions you could have. You could have less. I mean, if you put in the calculator y equals x to the third, you will not see 2 changes of direction. It'll look like it's all just going in the same direction. But it could have up to 2. It could not have more than that. Yeah. Okay, well, how many changes of direction do you say for a quintic? 4. So it either starts down here, that would be if a is greater than 0, or it starts up here and goes like that. So changes of direction. 1, 2, 3, 4. 1, 2, 3, 4. And you could just keep adding one more wiggle. The other thing that you'll say is, when it's an odd degree, right, you expect that if it starts negative, it ends positive, or if it starts positive, it ends negative. It always finishes at the other side, positive to negative. Same thing with a cubic, right? If it started negative, it ended positive. If it started positive, it ended negative. For a quintic, which was 5th degree, which is odd, starts negative, ends positive. If it started positive, it ended negative. And now for the even, it's not, right? For a quadratic, the parabola, if it starts positive, it has to end positive, right? If it starts negative, it has to end negative. And look what happens for the quartic. Because it's got 3 changes of direction, right? That means it's going to necessarily, it starts positive, it'll, then it goes negative, it starts positive up here, changes direction once, twice, 3 times, and the third one leaves it going back in the same direction it came from. Just like that. Okay, so we're going to look at data, and then we're going to have to compare it to the shape so that we can choose the right function to make our model with. Right. Now, if the last data you put in your calculator is that last line that we put in, then you should get a graph that looks something like this. What we need to know now is, well, how do I look at the data? How am I supposed to look at it? And this is how you look at it, right? First step, enter the data. We already did that. Second step, we need to turn on the plotting of points so that we can see what we just put in the calculator. And you do that, if you look at the calculator, what do you see above y equals? What does it say? Stat plot, right? That's what's going to allow us to see the plotted points. So in order to access that, you got to hit the second first, second, y equals, and what you should see up there, you see a bunch of these here, but we always hit the 1. I've never used anything below the 1. So you hit the 1 or you hit enter, and it should be that it's, at this point, it's highlighted on off, but it's blinking on the on. So if you want to turn on the plotting of points, hit enter, so that now it's highlighted on the on. You just turned on the plotting of points. Okay, now, if you want to see those points, then you want to go zoom 9, right? The zoom is right here, right? And the 9, if you scroll down and look and see what it says, that's zoom stat, right? So we want to look at those points that we put in under stat, zoom 9, and that's different data, but look at this data here. Yours should look like that if you still have that data in the calculator. Right, so it moves the window to be right around the points you put in. If you just hit graph, depends on your values. If your values are around the origin, you'll see them. If your values are not around the origin, then you're not going to see them. So zoom stat will make sure you're getting the data points right in your window. Now, if I didn't know before I looked at this data what kind of function to use, would I have looked at that and said that looks kind of linear? Yeah, that's a pretty good linear graph. Does it look like there's a change in direction in there somewhere? Nope, that's a straight line. You guys are seeing things if you think there's a change in direction there. All right, so let's see. Try this one. Put these 4 points in the calculator and then look at them and see what shape you see. All right, so enter the data, and then if you've already turned on the plotting of points, and you better have, right, then you just hit zoom 9 to look at them and see what you see. Which kind of polynomial does that look like? So you got one right there. So what does that shape look like? Yeah. I've seen one. Good graph. Okay. Zoom 9. There you go. 1, 2, 3, 4. What's the shape? How many changes of direction? Okay, so what is it? Yep, that looks good.
Looks like a trajectory.
Okay, good. 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 Okay, you already went ahead. Did you get that? What are you doing? Did you look at the data? Did you do zoom 9? Zoom 9. Just hit 9. Where's your point? Did you enter the data? Stat, edit. 1, 2, 3. Did you turn on the plotting of points? No, you still have it off. Right. Remember, quiet please. When you got to turn on the plotting of points, right? And you should have done it the first time I said turn on the plotting of points. Don't sit on your hands. I'm not helping you out if you don't even do the first thing to help yourself, right? Second, stat plot, make sure the plotting of points is on. And then ever after, if it's on, all you have to do is hit the zoom 9 to go to those points, right? And if you did that, this was what you saw. Now, compare that to our shapes that we just looked at as the functions. Which one does that look like? Yeah, I mean, there's one change of direction, which means it's probably a quadratic function, right? So if it's a quadratic function, then you're going to go to your calculator and go stat calc, but this time hit 5, not 4, because you're trying to approximate it with a parabola. If you do that, this is what you should have got for the answer, right? Y equals ax squared plus bx plus c. Here's the a, here's the b, here's the c, right? So you have to write that out. There's your model. It's a quadratic model for the data that you were given. Okay. Now, Somebody said that looks like a trajectory or something like that. Well, this came from a word problem. It came from a word problem where it says a man throws a ball off the top of a building and records the height of the ball at different times. Right? So that data that we just entered was the height of the ball based on the time. So at 0 seconds, right, just when he's letting go of the ball, it's at 46 feet high. So what is that telling you? The height of the building. He must be on a building that's 46 feet tall, or he's at some point 46 feet high, right? And then for 1 second, 2 seconds, and 3 seconds, we had these heights, and that gave us this here. Okay. Now, the second part of this question in the book, it said, use the model to estimate the height of the ball at 2.5 seconds. Right? 2.5 is not in our table. So how could I use the model to approximate the height of the ball at 2.5 seconds? Put x equals 2.5, right? So y equals negative 16 times 2.5 squared plus 33 times 2.5 plus 46. Put that in the calculator and see what you get. Say again? No. 28.5. I mean, if you look at the data you've got, it's between 48 and 1, so it wasn't going to be 88. It's going down at that point, right? So now, if you would have gotten this problem and not known about using the calculator, probably your instinct would have been, well, let's see, 2.5 is halfway between 2 and 3. How about let's just find halfway between 1 and 48? And you would have gotten 24.5. Now you would have been significantly off. If it was a multiple choice kind of problem, they probably would have had both answers in there to try to trick you. Okay. Now what about if I tried to find the height of the ball at 5 seconds? I mean, you could plug in 5. Since that's beyond our data, that would be more like a prediction, right? In fact, the ball was at 1 foot high at 3 seconds. So I think at 5 seconds is probably bouncing up and, it's a little too late for that. Once it hits the ground, we're done. But, this is more like an estimate, and that's what they called it. The SOL says you will be able to make predictions based on your model. That's what they mean. Once you've got your equation, plug in for the x, and you can calculate the value, which is just an estimate at that point. Okay? Try to do the same thing with this. Put in those points, look at the data, see what kind of function you think that is, that you can approximate the data with. What do you need, Trevor? Well, first you can just hit delete. Oh, that's not taken. You can always do like this, clear. Go up into the L1 and then hit enter. Yeah, that'll work. When you got a plot, did you have the plot? What did it look like? That's right. What does it look like? It sure does. You're still entering data? How long does that take? Did you look at it? Look like a cubic? That is correct. Room 9. Okay. You obviously have something on the y equals. Go to y equals. And clear. Okay, now go back to graph. Play Zoom 9. Okay, quiet, please. Quiet. Okay, so if you should have gotten a graph that looked like that, a plot, right? But that's a scatter plot. And based on this shape, what kind of function do you think it is? You know, it probably is a cubic. It looks like there's two changes of direction in there, so cubic. So we're going to use a cubic to model. So that'll mean go back to the menu, let's see, and do second or stat calc, let's see, stat calc, and cubic is 6, right? 6 for cubic, right? You got to pick the right function. And when you did, you should have gotten these coefficients right here, which if you write it, here's the model, right? You're not done until you've written the model. So I've put in the 0.049 x to the third minus 0.54 x squared, etc., down to the end, right? Now, if you put in your calculator that equation, that one right there, and then hit graph, you should see your model going through those points, right? If you enter exactly that equation. Now, is the model perfect? Does it hit every point? No. There's some error, like it's too low right here. It's too high right there. It looks like it's a little bit too low there. But it's kind of going right through the middle of all the points. That's the best, you know, the best fit cubic that we can find for that data. Did you get it, Sandy? Let me see. Did anybody try to do that and get the graph? I'm going to show you one more thing.
How do you get up to the next one?
Right arrow. Do you try it? Okay. Okay. So I'm going to show you one more thing, okay? Which is you could have the calculator take that stuff right there and put it automatically on the y equals so that you don't have to hand enter it, okay? I'm going to show you how this calculator thing here does not work for that. It gives me an error every time. So instead, I'm going to do it using my calculator over here. Let's see if that goes. Okay, so here's how you have the calculator do that step for you, right? You're going to go, first, I looked at my data and I said, I think I've got a cubic. So I go to the calculator, I go stat, you can't see that part, but stat, arrow over to the calc, 6 for cubic, right? And then I hit enter, 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 and I get those coefficients that we've already found, right? That's our regression equation. I know this is kind of dark, but let me see if I can brighten it up just a little bit. No, that does not help. It's actually the opposite of what you need to do. That's a little better. Okay, now, if you've got that in your calculator, if that's the last thing you did, then go to y equals, right? The y equals button in the top left, right there. You should have a blank line. You got it? Okay, so now you're going to be hitting on the calculator. You're going to go to this button right here which says vars, right? So you hit vars, right? And in the menu, you see the fifth one down says statistics. So you go down to 5, or you just hit 5, right? And then you don't want this one. You want the one that says EQ for equation. So you go right arrow so that it's highlighted on EQ. And now, see what's on the first line? That's your regression equation you just made. Right? So when I hit enter, it's going to put that whole equation on the y equals. Now, it doesn't quite look like it, but go to the graph now and see what it looks like. Graph. And you can see that it's drawing the line through the data. Right, so again, on the calculator, that's vars, stat, EQ, enter. And then it puts the equation at y equals, and you don't have to hand enter it, which almost nobody in here was successful doing. Right? It'll just put it there for you. Now, if I wanted to estimate, this data, if you remember our data here, it was stat, edit. Our data goes up through 8, right? What if I wanted to know what would the model say about the value of y when x equals 10? That would be a prediction, right? That would be a prediction. So how would I do that? You plug in 10, but the thing is, you've already got this in the calculator. If you go to the table of values, the table of values is giving all the model values for all the x values. You just scroll down the menu to 10, and there you've got your y value. So I think I've got it on the next slide right here. Right, so if you look at that menu, right, and I put 2 of them together so that we could see all the way from the -1, where we entered -1. That was the real data, right? And we had a value for 0 and 2 and 4 and 6 and 8. But we didn't have one for 10. So the estimate would be, looking at the calculator, 12.92. So that's why it helps. If you can put it on the y equals, then you can make all the predictions you want, right? Just look in your table of values. That'll be it. You see that, Sandy? Okay. It's all right. I know that she's trying. So you can see, I mean, notice the difference between the model and the data. I mean, it's not exact. In some cases, it's okay. I mean, this is -0.7, and that's -1. This one is 1.52, that was 2. I mean, models are not exact. I mean, just like the weather forecaster is not always right. You know, because what is he using to do his forecast? Models, right? Mathematical models. Okay. So now let's go back over this. Let's go back over this here, right? Recognize the graphs of polynomial parent functions. At the very least, we should understand linear, quadratic, cubic, quartic, right? We know what those shapes are. Investigate scatter plots to determine if patterns exist, right? Which is a whole lot like, given a set of data, determine the model that would be best to describe the data, right? We did that a couple times. Once we picked a quadratic, once we picked a cubic, right? Find an equation for the curve of best fit, right? What do they mean by curve? They're not going to say line, because it may not be a line. It'll be whatever is the shape of that graph. And make predictions using the data, scatter plots, or the equation of the curve. That's it. And the homework is all about put a polynomial in standard form, classify by degree and number of terms. Okay? Which shouldn't take long. What? Sure.